So far, we have talked about 3 different methods for how to solve a quadratic equation, and today we're going to talk about our last method, which is the quadratic formula. But let's first take a look at the 3 different methods that we have used. The first method was our graphing, and graphing can always be used, but it's not always exact, and so we can use it when we only need an approximate solution to it. We can solve them by factoring, which sometimes can be used. And we use it if a constant term is 0 or if our factors can be easily determined. We can solve it by completing the square. It always can be used as well, and it's useful when equations are in a situation where b is an even number. And our last step is the quadratic formula, which also can always be used. Other methods might be easier to use in some cases, but the quadratic formula will always give you very accurate solutions. Remember, our formula for the discriminant that told us what our roots are was b squared minus 4ac. Well, the quadratic formula is just a little bit more added to this equation, where x is equal to a negative b plus or minus, because we're going to take the square root of the discriminant, and all of that is over 2a. Remember, our x is going to give us our roots. So let's take a look. What if we had 24x squared minus 14x is equal to 6? Well, we want to get it into our ax plus squared plus bx plus c standard form. So let's subtract 6 from both sides, and we have 24x squared minus 14x minus 6 equals 0. Now we know that a is equal to 24, b is equal to negative 14, and c is equal to negative 6. Okay, so all we have to do is put it into our formula. So x is going to be equal to a negative 14 plus or minus the square root of negative 14 squared minus 4 times 24 times 6, and all of that is over 2 times 24. Now, remember, square root's like a grouping symbol, so we need to complete this or simplify that part first. And when we calculate that, we're going to be left with, I'm going to just go ahead and make my 2 negatives into a positive, plus or minus the square root of 196 plus 576, and all of that is going to be over 48. Well, when I simplify that, I'm left with 14 plus or minus the square root of 772 all over 48. And so now I just divide it into my 2 roots. So x is equal to 14 plus the square root of 772 divided by 48. And x is going to be equal to 14 minus the square root of 772 divided by 48. And when I plug and chug into the calculator, I find that my 2 roots are going to be x is equal to a negative 0.3 and x is equal to a 0.9. All right, let's take a look at another example. I have here 5x squared minus y minus 4. That means that my a is equal to 5, b is equal to negative 1, and c is equal to negative 4. Let's put it into our formula. So I have a negative 1 plus or minus the square root of negative 1 squared minus 4 times 5 times negative 4. And all of that is over 2 times 5. Okay, so let's do a little simplifying. So my x is going to be equal to 1 plus or minus the square root of 1. And then I got 2 negatives, that's going to be a positive. 4 times 5 is 20. 20 times 4 is 80. and all of that is divided by 10. All right, simplify a little more. So I get x is equal to 1 plus or minus the square root of 81 divided by 10. So that means that I'm going to have the square root of 81 is going to be 9. So I'm going to have x is equal to 1 plus 9 divided by 10. And x is going to be equal to 1 minus 9 divided by 10. And so that I find then that x is going to be equal to 10 over 10, which means x is equal to 1. And x is equal to negative 8 tenths, so that means that x is equal to a negative 4/5. So the quadratic formula, definitely a formula you're going to want to memorize, because a lot of times the factoring just takes a lot more work than being able to just plug and chug, or if you have irrational roots where you're not going to be able to factor it out, it comes in very handy to be able to just plug and chug and get your exact roots.